As we begin our discussion of angles, you should copy all of the vocabulary from the document on the wiki. In addition, I want to point out what a ray looks like. A ray has an end point on one end and a line continuing on indefinitely in the other direction, which is represented by the arrow. We always name a ray by using the letter of the end point first. So this ray would have to be named AB, not BA. And the symbol above the A and the B looks like a ray with the arrow pointing in the direction that it continues on. Opposite rays are two rays that go in exactly opposite directions, and they share a common endpoint. In this case, it would be this point here. Together, they form a line. Congruent angles are actually angles that have the same measure, so they are exactly the same size. When we form an angle is actually made from two rays with a common endpoint. So in looking at this picture of an angle, the names of the parts as rays would be an endpoint and two rays. When they come together as an angle, we actually change the names. The endpoint becomes a vertex, and each of the rays is considered a side of the angle. Each plane is always divided into three parts when it contains an angle. So in this example here, I have this angle inside of a plane. This angle has the endpoint X. It also has 2 points on the angle W and Y. There are three parts of the plane. The first is the angle itself, and this would be angle WXY. There's also the interior, which is where I put point Z, for example. That's the space that is inside between the two rays of the angle, or the two sides. And then we have what's called the exterior, and here I put a point V as an example. So those are the three different parts of an angle. A right angle has a symbol that looks like this in the corner or in the vertex of the angle to indicate that it's 90 degrees. Acute angles are angles less than 90, and an obtuse angle is an angle that's greater than 90 but less than 180. An angle bisector is actually another ray inside of an angle that divides an angle into two exactly the same size pieces, so it makes two congruent angles. It's very important that we use a standard convention when naming angles. For example, the vertex must be the middle angle. So if I look at this angle here that I can trace, A, B, C, B has to be the letter in the middle. Sometimes a drawing will also put a number inside of an angle, and we could call this angle 1. So this particular angle could be angle ABC or angle 1. When we write, when we write the symbol for an angle, ABC, with nothing out front, we're naming the angle. When we add an M in the front, that is actually the symbol to mean that we are now talking about the measure of an angle. So we're talking about the specific size of it. So for example, if I looked at my picture, I could say that the measure of angle 1 plus the measure of angle 3 equals the measure of angle ABD. I have to name this last angle using the letters because these numbers only refer to each smaller angle. In the case of congruent angles, I've started here in my drawing with an angle DAV. It could also be named VAD. It doesn't matter as long as the A is in the middle because it's the vertex. By adding a ray in the middle, I've now divided this particular angle into two pieces. I've used a single mark to show that the two halves are equal, and I could say that angle DAE is congruent to angle EAV. This means that I'm simply stating that they are congruent. When I put the M in front of the angle sign, now I'm actually stating that the measure of the angles are equal. And the reason we use an equal sign here instead of congruent is that a measurement is actually a number. It could be 89 degrees, 27 degrees, etc. So we say that measures are equal, but angles are congruent. Similar to the segment addition postulate, there's also an important postulate called the angle addition postulate. And it simply says that if we have an angle such as PQS, and R is a point in the interior, Then the measure of angle PQR plus the measure of angle RQS equals the measure of the whole angle PQS. It's simply a postulate that allows us to add and subtract angles. Congruent angles mean that two angles are congruent because they have the same measure. In this particular example, I have opposite rays MN and MR that happen to form a line. I also have the point P on this ray and Q on this ray. And I could say that angle PMN is congruent to angle QMR because they each measure 70 degrees. Moving on to angle relationships, the definitions for these terms are on the wiki, but I also wanted to point out the symbols. When we draw perpendicular lines, in order to indicate that they do in fact have a 90-degree angle, we use the small box symbol on the inside. Adjacent angles are two angles that are next to each other, and therefore they share a common ray. They may be congruent or they may not. They simply need to share one common side in order to be called adjacent. Vertical angles are formed when two lines intersect. The non-adjacent angles formed by the intersecting lines are called vertical. So in this case, by non-adjacent, we mean that angles 1 and 3 would make a vertical pair of angles, and angles 2 and 4 would also be a vertical pair of angles. Vertical angles are always congruent. A linear pair is formed when adjacent angles whose non-common sides are opposite rays. So in this case, I have two separate angles. The side that they don't have in common forms a straight line. Those are a linear pair. On this particular sheet, I'd like you to label and draw in the angles that I have modeled for you here. An adjacent set of angles are two angles side by side that share a common side. In this particular example, they also happen to form a linear pair because their non-common sides form a straight line. Vertical angles happen when two lines intersect and the two non-adjacent angles are congruent. At the bottom here is a sample of adjacent angles that are not a linear pair. So here I have two angles, they share a common side, but their non-common sides do not form a straight line. So those would be a different set of adjacent angles. Sometimes adjacent angles are a linear pair and sometimes not. And our last two special sets are complementary and supplementary. Complementary angles are angles whose sum is 90 degrees. So I started here with a 90-degree angle as indicated by the box symbol, and I drew a ray that bisected the two angles, or actually just divided into two. They're not exactly equal. And I got two different angles, but together if I add these, they're going to add up to 90 degrees. Similarly, supplementary angles are two adjacent angles whose sum is 180. So by default, these always happen to form a linear pair as well. And that concludes all of the information for this unit.